Hey guys, welcome back to Chemistry TV. Good to have you here. So let's focus on adiabatic expansion of an ideal gas. So if you are studying thermodynamics, if you are learning thermodynamics here, now this aspect is one part of thermodynamics that give a lot of student energy because there's a lot of derivations. You get so you want to stick to the end of this video here because I'm going to teach you how to derive what the adiabatic expansion formulas in order for you to solve problem. Like what I said, this is the fourth video. So we have done video one, video two, video three, and video four. Yeah, we have done video three, and going to be video four. In the last video, we did what molar heat capacity at constant volume and molar heat capacity at constant pressure. If you have not checked out that video, the link will be in the description below, or you see it here. So you need to watch that video. And if you don't watch, if you not start this video, if you not start this class from the beginning of this class, from the beginning of for the beginning aspect, like the introductory aspect to what thermodynamics, then I will leave the playlist at the description below. From the playlist here, you can watch video one, video two, video three. Before you can also watch video what four. Do you understand? So make sure you pay close attention. So now let's start breaking this adiabatic expansion of an ideal gas. So the first one to do here is that is the what statement of what first law of thermodynamics. And in the first law of thermodynamics, we have what the statement which was change in internal energy equals what change in Q minus what plus what W. Again, so this one is what internal energy. Here is what quantity of it. There is what is work done. So this is what the statement of what this is statement of first law of thermodynamics, and this is what we are going to use in what deriving this formula. So now let's look at what the word adiabatic. Now, what do you understand by what adiabatic? So we also have what called adiabatic process. In an adiabatic process or system, now there's no exchange of heat between the system and the surrounding. Right there. So there's no exchange of thermal what energy or heat between the system and the surrounding. So if you talk about adiabatic, is okay. Adiabatic, that is change in Q is equals to what? Zero. Do you understand? This is what you want to understand here. So because I talk about adiabatic process here of system, change in Q equals to what? Zero. That is the direct exchange of what? Of its thermal energy between the system and the surrounding. Do you understand? So this is the first one to look at. Now, let's look at what expansion. Now, when we talk about expansion, now work is done by the system. Right there. And when work is done by the system, it's called expansion. It's always what? Negative. So W is always equals what? Negative. And we have a called formula for what work done, which is called pressure volume work. Now in pressure volume work here, we talk about expansion. In expansion, W is equals to minus P change in P. Just a minus P change what V. So here what is pressure, here what change what in volume. Do you understand? So if we should replace it here, so here now let's replace this one and this one. Let's see what I'm going to do here. So let's see what I want to get. So here we're going to have change in E is equals to change in Q is what is 0 minus P change in V, right? So I'll go this one here because we have a bit of things to cover. So now it means that my change in E is equal to minus P change in V. So this is what first thing we have actually what achieve. Just tell you what first thing we have actually what achieve. Now, the great about change in E, just when we talk about change in E, we talk about change in internal energy. So we are going to talk about we have a formula that wants to relate to what change internal energy. Remember, in molar capacity at constant volume and molar capacity at constant pressure. Remember here we have molar capacity at constant volume and molar capacity at constant pressure, right? Now the formula for molar capacity at constant volume is what? Change in internal energy or change in temperature, right? So this is what we did in our previous video. Do you understand? We talked about molar capacity at constant volume, molar capacity at constant pressure. We derived formula. We derived how we got this one here. We didn't just arrive at this point here. We derived it. Do you understand? So that's why it's very important to check out that video. Then when we talk about CP, CP because what? Change what? Enthalpy or change what in temperature. Do you understand? So but we are talking about what internal energy. So this one is not actually what needed. So we have to wipe it out. So why to ask if we should what cross multiply here we have change what internal energy because what CV which what molar capacity constant volume change what in temperature. Do you understand? So now what we want to do here, it means that change in internal energy is equal to this guy equals to this one here. So this is what I want to do here. So here we can say change what internal energy equals to what CV change T, right? Equals to what minus P change what V. Do you understand? So it means I can eliminate this one here. So here I can have CV change T equals to what minus P change V, right? So this is what the next what we have arrived at next. Do you understand? So we have used this one, we have this one here. The next one to use there is what is the ID gas. And we have called the ID gas equation. So let me just put one here. We have called the ID gas equation. Because of P here. ID gas equation. Now what is the formula for the ID gas equation again? Now in ID gas equation here we have PV equals what nRT, right? Now if you're talking about this one here, we assume the mole of the gas to be 1 mole. So that is this n is always what removed because it's assumed to be what to be 1 mole. So if you assume this one to be 1 mole, here we have PV equals to what R what T, right? Now I want to remove this one here. You get so I will make P the subject of formula. So if I should make P the subject formula, here we have P equals to what RT over what V. Guys, that's RT over what V, right? So it means that I can bring this formula here. I can just say PV, right? Yeah, sorry. Yeah, I can say CV change T equals to what? Now, because here I have minus P. P is already RT over V, so it's going to be minus what? RT over V, right? Then change what? Change what in V. Now to make more sense, in order for this to make more sense, I can do it like this. CV change T equals to minus RT change V over what V. Can you see that? So I like at this point here, right? Now here we have T, here we have change T. So what I want to do here, because I have this one here, it can be in integration format, right? Now I can just say divide both sides by T. So I can remove this T from here. You understand? So in order for T to come to that point here, so I divide both sides by T. If I divide both sides by T, here I have CV change T over T, right? It makes more sense now. Equals to what? Minus RT over what T change V over what V, right? You can see that this guy and this guy were to go out. Do you see that? So this T and this T will go out. So what I have left is CV change T over T equals to what? Minus R change V over V. So now the next I want to do here is what introduce what my integration sign, because I can integrate this one here, I can integrate this one here, right? So if I should integrate both sides, integrate this one here, integrate this one here. So I have what my upper and what lower boundary. So I'm going to have CV integration T2 T1 change T over T, right? Equals to what? Minus R integration sign V2 what V1 change V what V. Can you see that? So what I want to do here is what my integration style, I will integrate it. So here I have CV ln T2 what T1 equals to, here I have what minus R ln V2 what V1. Can you see that? So but this not where I'm going to stop here. You get, so it now make more sense, right? It make more sense now. So now the next I want to do here, I want to remove what my arrow here. You understand? I want to remove my arrow and have relationship between CP and CV, which we also derive. We also derive that equation or that formula. So now the relation between CP and CV. So here we have CP equals to what? CV plus what? Arrow. Can you see that? Can you see it? CP equals to what? CV plus what? R here. Now, because I want to what makes on the solid formula here, I want to have R here equals to what? CP minus what? CV, right? So in the sense that anywhere I see I will replace with this other one. So this is what I want to do. Yes, I want to have CV ln T2 or T1 equals to what? Minus. So I will put what a bracket sign here, right? To enclose. So what will be CP minus what? CV, right? Then ln V2 or V1. Can you see that? Now, please don't get tired. And that's you. Some of you watching this video now, you say, "Is that this even needed at all?" I dare going to ask you is that because some students are funny. Students don't want to go through the hard process to learn something, so they look for shortcuts. Funny enough, there's no shortcut in chemistry. Now, is that what you learn in the hard way and master it, or you have to learn it in the hard way in the exam? You get, so you need to be disciplined. You get, so you need to take it step by step. You can see the way I'm taking it step by step now for you to understand. If there's anyone you don't understand, what you want to do is to pause the video and try to go back again and see how you can answer. Know it. You understand? If you have any question, only leave it at the comment section and we'll respond to that by the end of this video. So the next thing I want to do here is that now, here I have CV, right? So let me just. So here I have CV here. So yeah, I have CV. So what I want to do here is to divide both sides by what? CV. I can just say divide both sides by what? CV. Now, if I should divide both sides by CV here, it's going to be CV ln T2 or T1 divided by CV. Can you see that? So you can see that this will cancel out this one here equals to minus CP minus CV ln V2 about V1 over CV. Can you see that? So what I have left is that if I should open this bracket, because of course I want to open this bracket. If I should open the bracket here, I have what ln T2 or T1. You can see that this CV is not here again. So here we have ln T2 or T1 equals to. Now if I should open the bracket, here I have minus here, right? So it will be CP or CV, right? Minus CV or CV, right? Ln what? V2 or V1. Can you see that? So you can see that this and this will go out. Here we have what? 1. So now this is where things get interesting. So let me write this place out. Now, so what I want to get here, I want to get ln T2 over T1, right? Which is this guy here, equals to minus. Now, here I now have CP or CV, right? Yeah, I have CP or CV minus. Here I have what? 1. CV over CV divide, right? Cancel that. So it's going to be what? Minus 1. You have minus 1. Here I now have what? Ln V2 or V1. Do you understand? Now you want to define a new quantity because CP over CV, we have to define it in a way that you guys understand. So you can say let this. I forgot the sign you get. I forgot the name of this sign here. Is it gamma? Okay, it should be gamma. Let gamma equals to what? CP or CV, right? So it means that anyway I see CP, because I can't be using this one always. Just I can't be using this guy always. So anyway I see CP over CV, I'll put what? This gamma here. So it means that here I would have ln T2 over T1 is equals to what? Minus gamma minus 1, then ln V2 or V1. Can you see that? Now, so this is what I have arrived. I seem to break it down. You get, I seem to break it down. So I'll write this place out. So we're almost done with what? First formula here. So now I want to remove this minus sign. And the easiest way for me to remove this minus sign here is that I will invert, the S will go up, less will come down. You understand? So if I should carry V1 to up and carry it down, this minus sign will disappear. You understand? So the goal is to remove this minus sign. So if I should invert it here by removing the minus sign, here I have ln T2 or T1 equals to what? Minus, okay. So I'm inverting gamma minus 1 ln V1 or V2, right? So this is stuff here. Now, there's a way they did it here, which I cannot really fully understand. I didn't really understand. Now, yeah, this one we cancel out this guy. Then there's a way they did it here. You now T2 over T1 equals to V1 over V2 gamma minus 1. So this is now the final formula. This has to derive the final formula. To break it down, you can also break it down. So although this is the formula, but you can still break it down to be. Remember, here we have this one here is the what is the index, the power, right? Is affecting both. So here we can say T2 over T1 equals to what? V1 gamma minus 1 over what? V2 gamma minus 1, right? So if you cross multiply here we have T2 V2 gamma minus 1 equals to what? T1 V1 gamma minus 1. Do you see that? So these are the two formulas here. These are the two formulas. So this one relates to what? This is the relation between temperature and what? Volume. Temperature and what? And volume. So now we have to derive on that one. So this one is what? Relationship between pressure and what? Volume. Just we're talking about adiabatic expansion of an ideal gas. Now let's look at what the relationship between pressure and volume. Relationship between pressure and what? Volume. We have to use the general gas equation. You understand? In general gas equation, you have P1 V1 what? T1 equals to what? P2 V2 what? T2, right? So now we want to reduce to that point here. So if I should cross multiply, here I have P1 T, so P1 V1 T2, right? Cross multiply equals to what? P2 V2 T1, right? Follow me closely here. So now I want to reduce to that point here. Now this guy also is saying that what? T2 over T1 equals to P2 V2 about P1 V1. If you check very well, do you understand? This one is also the same thing with this guy. You also the same thing with this one here. This is called general gas equation. You get? So it means that T2 over T1 equals to what? P2 V2 over P1 V1. Do you understand? Remember, we have this formula here, right? T2 over T1 equals to the whole of this one here, right? So here, this is what you can say. Here we can say T2 over T1 equals to this guy, right? So here we have P2 V2 over P1 V1 equals to. Now here we have this one here because P2 over P1, T2 over T1 equals to this guy here, right? And this equals this one here. So we can relate all of them. So here we can say V1 over V2, right? Do you see that? So I want to eliminate this one here. So this one is out of it now. So my measure cosine here is going to be P2 V2 over P1 V1 equals to what? V1 over V2. Now let's reduce it. Now whenever you can separate this one here, you can separate this one to be what? P2 over P1, right? They have V2 over V1, right? Equals to, given that here is the power here, we can also reduce this one too, like you can separate it. So when you separate it here, you have V1 over V2, right? Times V1 over V2 minus 1. Can you see that? Now this is what I want to do here. Now here we have what? Minus 1. So this one will go up, so will come down. Do you understand? So I'll carry some up, I'll carry some down. So this is what I want to have P2 over P1, right? V2 over V1, right? Equals to what? V1 over V2, right? Lambda times. Now, remember, if I should carry some up, so and down, the minus sign will disappear. Do you understand? So I want to have V2 over V1. This is that. So now, if you check very well, this and this are the same, so they can easily work cancel out. So they cancel out here and have P2 about P1 equals to what? V1 what? V2. So here we have this formula here. So this is what the relationship between pressure and volume. We're talking about adiabatic expansion of an ideal gas. Do you understand? Adiabatic expansion of an ideal gas. So this is what we want to look at here. So these are the three key formulas. These are the two key formulas here we have derived. This guy and this one here. You understand? This is what relation between pressure, temperature and volume. Why is there a relation between what? Pressure. Now this is the relation between what? Temperature and volume. Why is there a relation between pressure and what? And volume. Now we also have the relationship that link. Let me check. We also have the relationship that link temperature and pressure. Temperature and pressure. But guess what? How that one came about, I can't still figure it out. So I'm just going to write for you. So that this video will not be too lengthy. You get. So this relationship. So I'm going to write the whole board here. I have the first formula here, which is what? T2 or T1 equals to V1 or V2 lambda minus 1, right? So this is what the first formula. Like the second formula we derive is what? Is P2 or P1 equals to V1 what? V2, right? The last one, which we are not going to derive, I'm just going to give to you. Last one is T1 lambda. Then here we have P1 1 minus lambda, right? So 1 minus T1 gamma, P1 1 minus gamma equals to T2 gamma, then P2 1 minus gamma. So this is what is formula here. But in the exam, you might be asked what to derive this one on these ones. So this one is the mother what formula. This is what the mother formula here. From this formula you got on here. But this one, seriously, how this one came about, I've just still mastered it. But at times you normally use one in the exam. And in our next video, what was solve problem of adiabatic expansion of an ideal gas. That's what we're going to look at in our next video. Do you understand? So you have to go through this video again. If you have not started the video from the first video to second video to the third video before this video here. Now there's a link that will take you to the playlist on thermodynamics. So you have to take you step by step. First video, second video, third video, then you want this fourth video. Now I don't want this video to be too lengthy because if I start some question now, then this video is going to be like 1 hour 30 minutes, which I don't want to be. So in the next class here, since you have already established this one, in the next class we're now going to look at how to solve problem. And the problem are a little bit complex, so I'll teach you how to solve problem. If you find this video helpful, please leave a comment section that this video is helpful. I'll give it a like if you actually understood what I have done. Thanks for watching. You can check out this one here. You can check out the next video here.